Alright, hi guys. Sorry I'm sick, but we're going to go through this video real quick on the rest of the notes, finishing out graphing, rationals, and then you'll have hopefully the rest of the time to work on homework and things like that, a couple of house cleaning items at the end of the video. Hopefully it won't be too long, but you know me, I just prattle on. Yesterday we talked about graphing rationals, and so what we learned was that many of the same rules applied. So if we were to go ahead and take a rational, we can still move it like right by subtracting, or left by adding, okay, down here with x. And then at the very end you can go ahead and you can add, or you could subtract, okay, whatever number. So in this case we would be going left 3 and down 5. So what that does is it takes our asymptotes, okay, because that left 3 down 5 is telling us we're going to move those asymptotes left 3 and down 1, 2, 3, 4, 5, and that's what is going to divide our graph up. So after that point we can go ahead and we put in our points, and yesterday we just learned the pattern for ones. Today we're going to learn the pattern for everything else. Okay, so if that number is not 1, so it'd go right here in the new first quadrant and then go down here. Beautiful, beautiful. Alright, so amazing artistic skills aside, that's what we talked about yesterday. What we're going to start off with is we're going to see if you guys can pick up on the pattern yourself. So I have graphed up here in different colors these different equations. So there's a 1, there's a 2, a 3, a 4, and I haven't done 5 because I want to see if you guys can go ahead and figure out that pattern and graph 5 yourself. 1 over x is represented by the blue function. It is right here. We talked about that it has dot 1 away. Okay. 2 over x is the red function right inside. 3 over x is green, and then pink. What I'm going to do to let you see the pattern is I'm going to just go ahead and zoom in on this graph right down here. You guys can pause the video, please, and copy down the graphs. And while you're doing that, I want to see if you guys can figure out what is happening. So how is the blue graph different from the red graph? How does the blue equation differ from the red equation? And keep on going up and down the list and compare and contrast. Alright, so let me go ahead and zoom in here. Hopefully you paused the video there and you were working on graphing these, and I'm guessing and I'm hoping that you were able to figure out that each dot is a certain distance away from our new origin where the asymptotes cross. So for the first one, that blue graph, 1 over x, our dot is 1 away. So it's 1 over, 1 up. For the red graph, going back and forth, where it was 2 over x, our graph was 2 spaces away. Now you'll notice it was still 1 up. Okay, still 1 in. So it's still on the inside of that quadrant, but it was just 2 spaces away on that particular intersection, I guess. It also is the same as reflected over to the other side. So if we were looking at our new asymptote, which is our regular asymptote, where they cross right here, it is 2 away and right down here. 2 away, right down there. So this compares with 3 to the x, so we should be 3 away. So if you look, we start here on our new asymptote, or wherever the asymptotes cross, and we are 1, 2, 3 boxes away, and that's where our point is going to be. We can be 1, 2, 3 boxes up. That's where our point is going to be. So it's always just kind of 1 on the inside. 1 on the inside, and you can reflect it over into the opposite quadrant to get the opposite 2 points. So going over, 4 over x, okay, that means we are going to be 4 away. So we go over 1, 2, 3, 4, and we're at this point right here. Over 1, 2, 3, 4, sorry, up 1, 2, 3, 4, and we're at that point. We can get the opposite points by going the opposite directions. So down here, if you scroll down here. So if you are picking up on the pattern, if we are having, scroll over, 5 over x, this means that we need to be a distance of 5 away. So we come back, and wherever we put our new origin, wherever those asymptotes cross, we need to go 1, 2, 3, 4, 5, and then our dot will be right here. And then we go up 1, 2, 3, 4, 5, and our dot will be right here. So I'm not too picky about how far in you go. You'll notice I was able to put an extra dot in here for the pink one. That's not too big of an issue. I don't mind either way if you are able to figure that out or not. It's actually a little bit of a secret that goes with it. So as long as you're connecting the two dots, I know we aren't all artists in here, and certainly right now I am feeling pretty crappy about all these drawings, but whatever. So we've gotten our 5 away here, 5 away here. We can go to the opposite side, 5 away and 5 away, and we just draw a curve through those. Beautiful. Make sure that you're not going to cross the asymptote. You guys listened to that silly, goofy song yesterday? Okay, so we're getting closer and closer to the asymptote, but we won't ever cross them. Our asymptote is actually right on the, oh gosh, this is awful. Right on the axes, the x-axis and the y-axis. Goes through 0, 0. Alright, so don't look too close at that. Good grief. Ugly, atrocious. Like how I feel. Alright. So let's keep on scrolling. The last graph that we have to do is -1 over x and -2 over x. So we'll make this, I guess, red for the first one, and then we'll go with black for the second one. So this one's going to be red, maybe. There we go, red. So all we have to do is we're going to have to go the opposite direction. So for the first one, we were in quadrants 1 and 3. Anytime you have a negative, you're going to be flipping them. So this part comes down here, and it's going to be in 4. This part goes up here, and it's going to be in 2. So you're just kind of reflecting it across. So instead of being in the right quadrant over here, we're going to be in the left quadrant, quadrant number 2. Same pattern, okay? So right now our asymptote is right here at 0, 0. So we make our beautifully straight line. Go home, Mr. Johnson, you are drunk. Oh gosh, that's ugly. And we go to the left this time and up 1 dot, and we go to the right and down 1 dot. So we're in opposite quadrants. We go ahead and we draw in our beautiful, beautiful curve, being very careful not to cross the asymptote, even though it might look like it. And we can go over here and do the same thing. So as long as you have your point, I'm pretty forgiving, because I know that it's a little tricky to be accurate in some of these things. So that would be -1 over x. If we go back up here, -2 over x, I'll make this one black. So let's go back down. Same thing, okay, but we're going to go left 2, and we put a dot, and then up 2, we're going to put a dot. We're just in the opposite quadrants that we normally would be. So when your a value is negative, you just kind of switch it up. And so we draw our curve in here, getting closer and closer and closer, right like that, and like that. So beautiful. Alright. Okay, and so that's what it should look like once you're done. So the black graph is -2 over x. The red graph is -1 over x. If you were going to do -3 over x, it would just be out here. 3 away, 3 away. Let me zoom out here. I have a little to-do list for you guys, so you can actually get some work done while I'm gone. Your homework, which hopefully the sub will pass out here, is due on Friday. Okay, we're going to have a test on Friday, so it would be very helpful if you could do that beforehand. Please also start to review for the test. This will be over all the rational targets, those 3. The first one was on simplifying. The second one was on equations, which we took our quiz on, and hopefully will be in the gradebook. And the third one here is on graphs. I'm not sure of how many each for how many questions for each, but we're definitely going to be reviewing probably when I get back. Hopefully that will be on Thursday. We'll get you the study guides and everything like that. So thank you guys. Sorry that I'm sick, and I hope that I can get back soon. So see you guys at some point. Bye.